Hey kiddos, today we are going to begin a new unit on logic. Okay, math is one of those subjects that is actually very logical. So what we're going to be discussing today are conditional statements. So this is going to be the part of geometry and the part of math that doesn't really utilize a lot of adding and subtracting and dividing and multiplying type problems. This is going to be more so a lot of actual writing. Yay. So we get to utilize our writing skills and really just thinking logically. So a conditional statement is a logical statement that has two parts. It has a hypothesis, which is usually your P, and a conclusion, which is typically your Q. A conditional statement is written in the if-then form. So, for example, if you give a mouse a cookie, then he'll want a glass of milk. Hopefully that book may be familiar to some of you. The if part contains the hypothesis. Now, it's very important that you understand this. It not including the word if. Okay, and the then part contains the conclusion, not including the word then. Very important that you understand that. So if I ask you, what is the hypothesis? Okay, notice it does not include the word if. Okay, when I ask you for the conclusion, it does not contain the word then. Okay, that would be incorrect. So in words, if P, then Q. And then in symbols, we have P implies Q. And that's what I'm looking at here. So notice the symbol here represents the word implies. That is the conditional statement. So for example, if a polygon is a triangle, then the sum of its angle measures is 180 degrees. The hypothesis is a polygon is a triangle. The conclusion is the sum of its angle measures is 180 degrees. Hopefully you guys caught on that I did not include the word if in the hypothesis, and I did not include the word then in the conclusion. All right. From conditional statements, we have something called converse. And to write a converse of a conditional statement, you basically just exchange the hypothesis and the conclusion. So you basically just switch the order. So it would become if Q, then P, or in other words, Q implies P. So you literally just switch it. The word if and the word then stay where they're at. You literally just switch the hypothesis and the conclusion. Negation, it's pretty straightforward. It means the opposite of the original statement. So if I say it is not true, then the negation of that would be it is true. So to write the negation of a conditional statement, you negate P, which is the hypothesis. The symbol for negation is this little squiggly here, and that would go before the letter. So not P is written as so. And obviously we would say that not P, and there is your symbol of what it would look like. All right, so example 1, rewriting a statement in the if-then form. So we're going to underline the hypothesis, and we're going to circle the conclusion, okay? Then we're going to rewrite it in the conditional statement if-then form. So first example, we have all birds have feathers. So our hypothesis, I'm going to underline, is all birds. And my conclusion is that they have feathers. So if I write this as a conditional statement, we would have if it is a bird, then it has feathers. Let's look at example B. You are in Texas if you are in Houston. So the hypothesis, okay, kind of a giveaway in this one because the word if is actually used here. So the hypothesis is actually you are in Houston. So therefore the conclusion would be you are in Texas. So if we write this in the conditional statement, it would be if you are in Houston, then you are in Texas. And C, all 30-degree angles are acute angles. So our hypothesis is that all 30-degree angles, and the conclusion are acute angles. So our if-then statement or conditional statement is if, oops, kind of accidentally moved all that. Didn't mean to do that. If an angle measures 30 degrees, then it is an acute angle. All right, D. Our hypothesis here is actually going to be x equals -3, and our conclusion is 2x plus 7 minus or equals 1. So our if-then statement would be if x equals -3, then 2x plus 7 equals 1. E. All even numbers are divisible by 2. So the hypothesis is that all even numbers, and the conclusion is divisible by 2. So our statement would be if it is an even number, then it is divisible by 2. And F. Dogs have fur. So our hypothesis, dogs. Our conclusion, fur. So our conditional statement is if, gosh, it keeps doing that. Crud. If it is a dog, then it has fur. All right, so hopefully you guys kind of caught on to how we can identify our hypothesis and our conclusions and how to put it in the if-then form. So now let's look at negation. Pretty straightforward, okay? Remember, the negation is basically making the statement the opposite, okay? So the ball is red. The negation of that would be the ball is not red. B, the cat is not black. So the negation of that would be the cat is black. C, the dish is not hot. The negation of that statement would be the dish is hot. And D, today is Wednesday. The negation would be today is not Wednesday. All right, moving on. Hopefully found negation pretty simple. So, writing conditional statements, we're going to write the conditional and the converse. Remember, converse basically means you just switch the order. So, just a note here. Conditional is P implies Q. So, therefore, then the converse, okay, you switch the order, so it would be Q implies P. All right? So, example A. Dun, dun, dun. Let P be you are a guitar player. And we're going to let Q be you are a musician. So, we're going to put this in our conditional statement. So, if P, then Q. So, when I rewrite it, we get if you are a guitar player, then you are a musician. Notice I tried to color code it. I kept the hypothesis in one color, and then I use a different color for my conclusion just to make sure I keep making that note of the difference. And then I actually use a different color for if then so that I also remember that the word if is not part of the hypothesis and that the word then is not part of the conclusion. Now, here's an interesting question. Is this statement actually true or false? If you are a guitar player, then you are a musician. True or false? Hopefully you said true. Okay, now let's look at the converse. So for the converse, remember all we have to do is switch the order of the hypothesis and the conclusion. So this time it'll be Q, if Q, then P, or Q implies P. And we get, if you are a musician, then you are a guitar player. Now is that statement true or false? Hopefully all you band people would agree that that has to be false. Okay? If you are a musician, then you are a guitar player. No, 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 no. You could play the piano, you could play the trumpet, you could play the violin, the sax, so many other instruments. Okay? If you are a musician, you do not have to play necessarily guitar. So that statement is false. See the logic in all of this? All right, B. Let P be, so our hypothesis is going to be the stars are visible. And then let Q be, our conclusion is going to be it is night. So our conditional statement states, if the stars are visible, then it is night. So what do you think? True or false? If the stars are visible, then it is night. I believe that's going to have to be true. Now let's do the flip side of it, the converse. Okay, so we're switching the order of P and Q, and you would get, if it is night, then the stars are visible. Now I'm sure you guys have gone outside before at nighttime and have looked up at the sky and have noticed you can't see the stars before. I'm pretty sure that you guys have done that before. So in this case, this converse is going to be, I didn't mean to move that. Converse is going to be false because technically it could be a cloudy night, right? Clouds could definitely block the stars from being visible. All right. Yeah. Oh, yay! Yippee! How fun. I know you're just smiling so hard. You get to do this one on your own. So, remember, P is our hypothesis here. So, X is less than 100. And then Q is going to be your conclusion. X is less than 25. So, for the conditional statement, it should be if P, then Q. Then tell me whether you think that statement would be true or false. Then on the converse side, you're going to flip it. If Q, then P. And again, let us know, or let me know, sorry, if you think it's true or false. Example 4. We're going to write the conditional statement in the if-then form. Then we're going to write the converse just like before. And we're going to decide whether it's true or false. So kind of the same thing. I'm going to add one extra little step, though, to this. So I don't know if you need to write this down to remind yourself. But I actually want you to underline. So let me write this. The hypothesis. We will underline. And guess what we're going to do with the conclusion? And I know that is so horribly written. But you know what it says. Conclusion. We're going to circle it. Okay? So just kind of get in the habit of doing that. It's a good thing. So we have A. An angle measure of 167 degrees is an obtuse angle. So the hypothesis, angle measure of 167 degrees. The conclusion is an obtuse angle. So if we write this in the if-then form, we would get our conditional statement to be, if an angle measures 167 degrees, then it is an obtuse angle. Now, ask yourself, is that true or false? Hopefully you agree and you understand what obtuse means. Obtuse is an angle, what? Greater than 90 degrees. So, the answer is true. Now the converse. Remember, converse, all we do is switch the order of the hypothesis and the conclusion. I'm sure you're getting tired of me saying that. So the converse is, if it is an obtuse angle, then it measures 167 degrees. Well, does that necessarily have to be true? If it is an obtuse angle, then it measures 167 degrees. Well, it could be what? Could technically be 150 degrees, 91 degrees, 100 degrees. So we're actually given a plenty of different different options as far as it being obtuse. So this answer is most definitely then false. We're almost done. Oh, Eureka! Looky here. Another one of those on your own kind of problems. Notice I did already help you out here. I identified your hypothesis and your conclusion. You are in geometry class, so you always have homework. Let's see what you guys come up with for your conditional statement, deciding whether it's true or false, and the converse statement, and then deciding if it's true or false. So that is all, folks. Logic.